Okay, so hello everyone. My name is Pedro Jesus, and as Javier mentioned, we will be talking about debugging memory leaks in .NET MAUI. But the things that I will show you here can be used on any .NET mobile framework or application, and even cross languages and platforms. Because the ideas behind here can be the same for other languages and frameworks. So let's get started. So we will review some key concepts about memory management, and then we go to a hands-on session to show how you can debug memory leaks, including that you have, and some techniques that you can use in order to find a memory leak and solve it. So let's go with the key concepts. So first of all, you needed to think about the reference and value types. And I'm pretty much sure that most of you already listening or heard something like that, like reference types are allocated on the heap and value types are allocated on the stack. And those affirmatives are not entirely correct. Okay, there is also a discussion on the C# language GitHub. Is already closed where they mentioned that they should drop this concept like value types or structures go on the stack and the reference type, aka objects, go on the heap. And they changed that on the documentation, and you see the more recently documentation, you will not see those statements. So a better definition, I would say, that I grabbed from the talk from the .NET Conf, called the new features in .NET 9 JIT. I really recommend you to watch that. And this definition is that have types like objects are normally allocated on the garbage collector heap. And sometimes you can you can allocate those reference types on the stack. For example, you can use the stack alloc to allocate array on the stack. And also the just-in-time compiler sometimes, at least on the .NET 9, can perform some optimizations. And instead of allocating your object on the heap, on the managed heap, we allocate it on the stack frame. And if the object is allocated on the heap, the lifetime of this object will be determined by the garbage collector. And then for the value types definition, or on C# they are known as structs, they are allocated on the stack normally, but they can be boxed. And when they are boxed, they will live on the garbage collector heap. And if they are living on the stack, the lifetime is tied to the lifetime of the stack frame. So as soon as you leave that stack frame context or that method context, the stack will be cleaned up with that all the variables and memory that you have been used there will also be cleaned. And if you are on the heap, like if you box your struct, then the lifetime is determined by the garbage collector. And often this value will be unboxed. That means like if you inside a method you want to access that value of that value type on the heap, it will be unboxed. That means it will copy its values to the stack, and then you can use that. And this is kind of immutable thing, like you will not change the actual reference that is on the heap. You will use a copy of that reference. And going further, the definition of what is a garbage collection. So the garbage collection is when the operating environment automatically reclaims memory that is no longer being used by the program. It does it by tracing memory starting from roots to identify which objects are accessible. I'm pretty much sure that most of you already heard about this definition. And this definition is like correct, but actually is not 100% correct, As terms of comparison, is the same as you say that the firefighter's main goal or job is to drive a red truck across the city. And you're not entirely wrong, the firefighter can do that, but it's not the main goal of the firefighters. That is not the main reason to that. So the garbage collection is not actually that. The main point of the garbage collection is to simulate an infinite amount of memory to your software or to your application. In other words, if the garbage collector will not collect your objects, that means you'll not clean up the memory if there is a lot of memory is still available for use. So if you think in an imaginary computer or mobile device that has infinite memory to run your application, then the garbage collection will never happen. because there will not be pressure on the memory, so there is nothing to be cleaned there. And this is very, very important because some issues and reports that I have been seeing on some projects that I contribute with regarding the memory leaks are people not enforcing a garbage collection. So for example, they are navigating to 3 deep pages and then they go back to the root. So they expected that 2 pages will be collected right after they navigate to the root page. And sometimes that will not happen because that will not be memory pressure enough to trigger a GC collection. And then then the developers will have a false sense or a false idea that there is having a memory leak, but there is no memory leak actually because the garbage collection didn't run. So when you force the garbage collection, then you see that those objects are collected. So it's something very tricky and it's very detailed, but can cause you some confusion there. And then let's talk about managed and unmanaged resources. So managed resources are everything from the .NET world, and the .NET garbage collectors knows about it and can manage it. So everything that you create using C# and that is related to the .NET, you don't need to care about clean that up. You know, the garbage collector will take care of that for you and all those management on the memory, where they should be allocated, what the memory address would be, and if they should be moved or not. And then we have the unmanaged resources. And those are everything outside the .NET world. So like if you call a C++ code or a Java code from your C# with the pinvoke, for example, everything that is on this world is unmanaged resource. And the .NET garbage collector does not know anything about it. So it cannot manage and handle it. So it's the responsibility of the developer to clean those objects at the end of its usage. And in MAUI applications, you can think those unmanaged objects, unmanaged resources, as the objects from the Java or the Kotlin world, or the Objective-C and Swift world, in the case of the iOS. So for example, on the Android, if you create an accessibility listener, for example, that inherits from Java Lang object in those Android interfaces there, then you create on the .NET world that object called that accessibility listener, but on the Java and the Android world, you create a Java object. And this Java object cannot be handled by the .NET garbage collector. So it may cause leaks. And if you have cycle references that it is, for example, you have object A and object B. And object A has a reference to B and B has a reference to A. If those are managed objects, then the .NET can handle those very well. Otherwise, they may have issues if one of those objects holds or are unmanaged resources. So pay attention on that. And actually in .NET MAUI and on .NET Mobile itself is very, very common. We have unmanaged resources, but since we write everything in C#, they are not very clear. They are unmanaged, okay? So let's go to the hands-on session. So the first project here that we will be looking for is a bug on the community toolkit. Actually, it was a bug because it's already fixed, and it was a memory leak happening on the touch behavior. So here we have the sample project provided by our user, and we have here just a main page with 2 pages, one using the gesture recognizer and the other one using the touch behavior. And the XAML of those pages are pretty much the same in terms of layout. So you have a scroll view, a vertical stack layout with a label there as a title. And we have another vertical stack layout using a bindable layout there. So you'll be a small collection with 3 items. And in this page here, it's using the tap gesture recognizer as a gesture, as a touch strategy to grab, capturing the touch on inside this horizontal stack layout. And at the code behind, I have a normal code and I have this here, that is my memory test that I will show you in a few moments. And I just adding a reference to this page and the binding context of this page. On this case, it will be the view model because this sample is using MVVM. And then I have the touch behavior page, which the same layout as I showed on the gesture one. But here I am using the touch behavior from the community toolkit. And on the code behind, I am doing the same thing. I am adding the memory test. I am adding those objects, the page itself and its body context to the memory test here to see if they are leaking or not. And this memory test is a class that I use sometimes to investigate if something is leaking or not. And you can replicate this on your own project as well. It's pretty straightforward. So I have here a collection, then I choose a list to be this collection of weak reference of object. And then I will hold these objects here on the list, the objects that I want to inspect. Then I have this count property here, not using on the sample, but sometimes it's really useful to see how many items are leaking there, or not leaking, actually alive is yet. Then I have a simple method that will just add the object, the reference to that object to the collection. And I am wrapping this object in a weak reference. So weak reference is a special type in .NET that will not hold a strong reference to that underlying object. So that means if this object should be collected, will be marked to be collected by the garbage collector, then this reference here will not account as a strong reference. So the garbage collector will be able to clean up this object. And it's really interesting because this can save you a lot of in terms of memory leak issues, and we will see in a moment. Then I have this isAlive async method that is just show up to me if there is something alive yet on that collection. So I will run the GC, and I will show this code in a little bit, and then I do a loop inside my collection. And I grab the weak reference, then I use this try get target here, and if I can get the target of this weak reference, that means this object is still alive. So I will present a display alert here showing me the name and the type of that object. Otherwise, I will just remove the item because that target is not alive. So I don't need to keep it on my collection. And on each run of this for loop, I will run the GC again. I do a full GC collection. And this is necessary because sometimes objects on the .NET Mobile needs more than one GC collection a full GC collection to be collected. They can live a little bit longer, and this is not will be a leak. Maybe it's just the object will be a little bit longer because on the unmanaged side there is still a reference there, but they will get collected at soon. And finally, the run GC method. So I have here a full collection, calling by this GC collect. Then I will wait for pending finalizers. So some classes may implement finalizers to help to clean up and manage resources there. And if those objects, if the object implements a finalizer, this object will not be collected at the first GC collection. The first GC collection will just be enough to tell the system that it should trigger that finalizer. And then we have this method here that we are waiting for all pending finalizers that the garbage collector found on this first collection. And after these finalizers are run, this object will be able to be cleaned up. So I do another full collection there to make sure that I will clean up those objects. And because of that, I have this two GC collectors call here. So to gain time, I will not build this application, but I have already here installed it. This is this memory leak application here. And let's start that up. Let's just see, yep, that will do the job. So it could take a while. Oh yeah, there is something that I needed to configure. 1 second, ADB, no suspend. I believe that was the issue there. So let's try it again. And okay, now we have the application. I will already explain this one in the next step, right? So here I have this main page. I have here a total memory showing me how much memory I expand. So if I go here on the gesture recognize page, let's do that twice and analyze memory. That will trigger this isAlive async method, then I don't have any display alerts. So it means that the gesture recognizer page is not leaking. So let's go to the touch behavior page 2 times as well and do the analyze memory. Then you will see here that I have a memory leak. And it's telling me that the touch behavior page is causing a memory leak. And the touch behavior view model will also is also leaking. So I can run these a few times just to make sure that this object is not live a little bit longer. But as you can see, it's still leaking. So for .NET Mobile, what we need to do is to run to collect a .NET GC dump, and with that we use the DS router tool on the .NET DS tool. And this variable here, the bug monoprofile, then this is the IP address of my emulator, and you pass the parameter suspend, and when this is connected. So the suspend will do what? When I start my application, it will hold up on the splash screen until I connect my tooling there to profile the application. So I will let that as suspended because in this version, the .NET version of this .NET 9 version of this tooling, there is a issue where the GC dump is not creating correctly the dump. So so in order to avoid that, I will already do in this way because I tested that, and this is our workaround for that issue. So it's telling me here that to run the diagnostic tool, I needed to run this command, .NET trace collect -p and this address here, this ID here actually, and this is the process ID. So basically I needed to grab this process ID to grab the collected dump and also the .NET trace there. And this value will change every time that you turn on and turn off this DS router. So let's go to the memory leak project, and this will run here, and this is frozen on the splash screen. Then I will do the .NET trace collect, and this will start a collection. And this one is for profiling matters, and I will not talk about this right now because it's not the focus of the presentation, but this is like if you want to profile some performance issues, this is the tool to go. So now I have here my page again, and let's go to the touch behavior page, and let's do it twice and confirm that we have a memory leak there, and 2 times just to be safe. And now I will run the .NET GC dump collect, and I will paste I will use the process ID that is 26180. And then I will have this writing GC dump and this finishing writing. And I can open this memory dump right on the Visual Studio. So I will use this one here, and it should open in a few moments. So I have this memory dump for my Android application at the very moments. It's like a snapshot. And I will look for the touch behavior page here. And I cannot see anything, but as I showed a little bit ago on the application, it's still leaking. And this is something very sad about the tooling. So what happened here? The tooling for the .NET Mobile is not as sharp as the .NET Windows when you run something on Windows or ASP.NET Core, and it has to do because of the runtime. So the .NET Mobile, that means Mac Catalyst, Android, and iOS, runs on top of the Mono runtime. And when you run a Windows application or ASP.NET application, we are running on top of the .NET CLR, that is the Microsoft runtime. And those toolings are very, very good at the Microsoft runtime, but not on the Mono. And I know that we had a merge on the one.NET, you remember that, on the .NET 5 or 6, where they merged the .NET CLR and the Mono, but there is still the Mono there. And the team is working to improve those toolings for the Mono runtime. So far, we don't have a lot of integrations on the Visual Studio and etc. So here's some workarounds, okay? So in this case here, when you are not seeing the object leaking, you can click on show the objects, and then you will see the touch behavior page there, and there is 2 instances of that. And this makes sense because we go 2 times to that page. But the page is not leaking, right? We know that what's leaking is the touch behavior. So I will I will delete that page suffix there, and I will show the touch behavior here. And I have the touch behavior from the community toolkit.maui with 6 instances. And this is expected because the page will hold 3 elements, and those 3 elements will hold 1 instance for the touch behavior each. So 3 times 2 is 6. So you have here 6 leaking instances. And if you go to the show hot paths only, you will not show anything because it's considered as a dead object. So you can uncheck this, and then you see all the references to that leaking object. And here it starts to the debugging memory leaks thing. So we need to look here on all those types that holds a reference to the touch behavior, and you should investigate which one could be causing a memory leak. So we have here 3 event handlers. And as far as I know, event handlers are the most, devil things about memory leaks. A lot of people see event handlers as a memory leak prone thing, but sometimes they aren't. Okay, so but let's dive into them. So I have this event handler here. If I go to expand, those are on the horizontal stack layout and the Android click listener implementation. So those Microsoft MAUI from the MAUI, I will ignore them for now, because that would mean that the leaking is happening inside the stack layout implemented by the .NET MAUI. And if it was the case, the gesture recognized page would be leaking as well, because it uses the same layout there. So with that, I can ignore everything that is related to the Microsoft.MAUI. So this one I can ignore, and this one here I can ignore as well. This is just the behaviors collections inside of the control that will hold all the behaviors for each control. So I have here this Android view touch args event handler, and I have this accessibility listener event handler. So now I went down for five possible causes of the leaking to just 2. And looking at the top here, I can see that I have this accessibility listener leaking as well. So now it becomes my top 1 suspect to be causing the memory leak, the accessibility listener. And it has also the same amount of memory. So going back to the touch behavior and expand the accessibility listener, we can see that we have here a cycle detected. That means what? That means that the accessibility listener has a strong reference to the touch behavior, and the touch behavior has a strong reference to the accessibility listener. And as I mentioned on the slides, the .NET garbage collector can handle this very well. The cycle, it's easy to handle. But here we are talking about something that is unmanaged as well, because the accessibility listener is a Java lang object. So let's take a look. And oh, by the way, I can go here and go to the definition, and this will point me to the definition of that implementation. And I will jump right on the Android implementation. So as you can see, the tooling is very, very tied together. So here we have our accessibility listener, and let's just hover the cursor here to highlight where it is being used. So we create an instance of this type if there is accessibility manager there, okay, and we use it again on the attached from to clean up those resources. So we remove the listener from this object, and we dispose of the listener, and we set it to null. So my first assumption is that something is not being correctly cleaned up, and that is true. But I will show you another way to fix this one, because it will be more didactical, all right? And I want to show you some tricks as well and some concepts as well. So let's dive into the accessibility listener implementation. So it inherits from Java lang object. So as mentioned, that will be a Java object when this object will be created as well. And I implemented those 2 interfaces here. And here we have the strong reference to our touch behavior, as I mentioned before. So because of that, we have the cycle. And then we have just the interfaces methods here implemented. And we have this dispose that will just clean up that reference, but it's not being enough. So what I can do here? So in order to avoid cycle references in some scenarios where you cannot apply easily an disposable interface or easy cleanup there, what you can do is to take advantage of the weak reference. So I will copy this puppy here, and I will make this property, and we'll take there in a second, and I will promote this field to be a weak reference. And this field will not be nullable anymore. And here at constructor, I will just wrap my touch behavior reference to be a weak inside this weak reference. And at my property, I will just look if I can get the actually object and I will return it if I can, and I will return null otherwise. So if this object is still alive, I return a reference to it, otherwise I return null. And on those calls here, I will just call the property instead of the field. And now I don't need this dispose here anymore, because the wiki reference will make sure that this code that this will not hold a strong reference to that, so the garbage collector will not look at this as a root. All right. So with this change here and not change anything on my touch behavior, I can go there, deploy it, and see if the leak is happening. So let me close this pub up, and I will go on this fixed version of my memory leak project. Oh, and by the way, let me just set this pub here, because I will use a recorded memory dump that I have here, so that we do not expend too much time here. So here I have my fixed version, and let's take a look again. Let's go to the just recognize a page 2 times and do analyze memory. And whoops, something went wrong. And okay, now it's gone. So actually it's not wrong, but that is something that I always mentioned before, that sometimes that object that has some .NET Mobile there will live a little bit longer. So I am clicking here and there is no reference alive anymore. So yeah, that could happen, and is not very deterministic when that will happen. And let's go to the touch behavior 2 times again, and now I don't have the memory leak here at all. So let's do that more a few times, and as you can see here, I do have it. Let's do that, but when I do it again, there is no more there. So it's because of that. Sometimes that will take a little bit longer to the objects be collected. And that is happening because since I'm on using the .NET MAUI page, there is a content page and some controls. Those controls have there is a native control, and that native control can live a little bit longer. And now with that, we fixed the memory leak on this pub here, but let me show you one more thing. Here we have some event handlers. And since this guy here is not being cleaned up, these event handlers will not be unsubscribed. So as I mentioned before, event handlers has the reputation to cause memory leaks. And if I am not unsubscribed to that, by the common sense, it should cause a memory leak. And how I know that is not being cleaned up? Because the issue is because this element is already new when I run this method here. So there is a short ILE return here. So when you grab on these lines here, this method is exited. So the other fix will be to set the bindable collection to null, checking the bindable if it is null, and then I do and then the cleanup will happen. But moving back here on the onTouch, these onTouch are assigned on the platform touch view no matter what. When I attach the behavior, I attach to this event, and this event is an instance event, so it holds a strong reference to this object. So in common sense, it should cause a memory leak if I do not unsubscribe for that. And that was not the case as I proved it to you here. All right. And the case is, if you take a look here, we have 3 objects in these houses here. So we have this visual element, that is the .NET MAUI shared control. We have the Android view, that is the platform control, and we have the touch behavior. And all those 3 elements will have the same lifetime. So if have the same lifetime, no matter what, then the event handler will not cause a memory leak, because this view here, which holds the event handler, has the same lifetime as the subscriber, which has the same lifetime as the visual element. So since all those 3 will live at the same, you will born at the same time and you die at the same time, then there is no issues here to not unsubscribe to this event handler. And I am telling you this because on the wide, I have seen a lot of applications and projects that developers do a lot of extra work to solve a problem that does not exist. So they try to solve like, hey, I needed to unsubscribe this event handler, otherwise it will cause a memory leak. And sometimes it's like, probably you will not cause a memory leak there, so you You don't need to came with a fancy architecture that will disable your pages or your custom controls or whatever, you know, because if they have the same lifetime, then you are good. So as I mentioned, let's take a look on the memory dump for the fixed piece that I have here recorded already. So if I found, oops, not this one, the touch behavior here, then I have nothing showing on here. And if I see now, I have these dead objects, and now they are actually dead. Okay, so there is no issues there anymore. And as I mentioned before, this is issue with the tooling on the Android side, because sometimes you can have how I can say, you can have false positives there, but on this one you need to use the show that object, because this helper was showing me that object was leaking, and now there is no object leaking, so those objects are actually dead. And with that, I have to say that if you can use a Windows application to profile your project or test the memory dump, then you should use the Windows one, because the tool is way better integrated. And that is the case for our second demo, that is issuing a memory leak that I have been working on the .NET MAUI project itself. So I have here the .NET MAUI project, and we will run the memory dump on top of the unit test. So this is a device test, and the device test is basically a unit test that runs inside the platform. So this unit test here, in this case, I run on the Windows. So it's a Windows application, but I could run that on the iOS application or Android application, and that will run the unit test inside that context, all right? And so this is really good, because I don't need to mock anything. For example, this content page is the .NET MAUI content page itself, so I can really test those objects without mocking it. So let's take a look on the test implementation to see what it's doing. So first of all, I have here a page that is a navigation page, and I have a content page inside it. Then I will create a new window and put this page here, this navigation page, as the root page of that window. And after this window is created, I will perform those actions here. And those actions is that I will create an animation page, and you'll take a look at that in a second. And I added this page too as a wiki reference to inspect if this page is leaking or not. Then I await the root page to be loaded. Then I navigate to my second page, that is the animation page. Then I wait it to be loaded. Then I grab the animation object of that page and put it inside a wiki reference. And this animation is already a wiki reference, as you can see here on the tool, on the tool ship here. And then I wait for 2 seconds just to make sure that the page will load and the animation will run at least for 2 seconds. Then I navigate to the root, and I await the page to the animation page to unload. So that means that the .NET MAUI will clean up from the memory. And just to be sure, safer here, extra safe, I will set this to null. It will make sure that I am not holding any reference to this page too. Normally, you don't need to do that, because the garbage collector is smart enough to know there is no, this reference is not being used anymore. But just to be extra safe, I added it here. And then we do these accessor extensions, and I wait for the garbage collector, and we can pass all the wiki references here. So let me pass the page wiki reference and the animation wiki reference. And now let's take a look at the animation page here. So it's just a simple content page where I have a button here and the wiki reference to the animation, and a boolean where I specify that should create animation with a closure or not. So closure is something when you capture the object instance inside the lambda or anonymous function. In this case, it's capturing because I'm using this counter button that is implemented at the page level here inside my lambda. So this will capture some context there. So we have a closure there. And we have the no closure version, and I marked this lambda as a static to ensure that will not be a closure there. And I just doing the first line here. Then I created the animation and added that as a wiki reference to my property, and then I do a commit animation. And this leak happens when the animation is configured to run infinitely. So it just passing a true value here. So this animation will run forever. Okay. So with that in mind, let's take a look to the memory dump that I recorded. So since I was on Windows, then I could go on the debug and I could, oh, I would believe that we're not showing up here, but will be an option called the save as dump. Okay, so if I pause the process or if I do or if I pause on a breakpoint, I will have an option to save the dump. And this will not save only the memory dump, but will save a lot of information. So you can like debug in managed code, so you can simulate as the application was running, and you have access to the breakpoints and the memory states there, so you can inspect variables and all of that. So this is really, really amazing. For this case on this presentation, we will debug the managed memory. So I will click here, and this will initialize for me a debug session. I recorded the debug session. As you can see here, the tooling is on the debug version right now, and here is the option that I mentioned before, save dump as, and that's where I clicked it to grab the memory dump. So what I am looking here is the animation object, because I know this is leaking. So I will grab here the animation, and as you can see here, let's see how much time we have. Okay, we have 4 minutes. Then I have here the Microsoft.maui.controls.animation, and I'm interested on this one. And since I was running on the Windows application, then the tooling will be more sharp here, okay? They will be more accurate. And the hot paths in this case will show me exactly where the leaking was happening. And in this case, the animation is beholden by these S underline animations. So this collection, this is a dictionary where I have animatable key and info object. And this is beholden by this collection that is a static collection. And if you take a look here, I have my animation extensions info, and there is 2 references there. So, and it happens because I ran the test twice. So because of that, we have two references there. And let's take a look also on the animatable key, because animatable key. Now, yes. So as you can see, is also linking. And I use the data because, as you can see, the collection itself is using animatable key and the info. So just to make sure that both also be leaking, and should be. So let's take a look. Let's go to the definition here. And it's grabbing me to the animatable key reference, but I want to go to this definition here, the collection one. It is on the animation extensions. And let's dive into the info object to see how it looks like, because it could be causing the leak. And I have here the info is just a model class like a DTO where I hold some fields and properties. And I have here the animatable, the animation object that is the control and the animation happening. And is marked as to be a wiki reference. So it should not be holding a reference there and is not doing anything with this reference, is just exposing. So this, I will not suspect that this is causing a memory leak. So let's take a look at the animatable key. And the animatable key receives the animatable and saves it on the, oh, actually I am using the already fixed code. I'm sorry for that. We should be using the old code there. But anyway, it's using the animatable here. And right here probably will be the fixed version. Oh gosh. Let me just dive into the source code of the .NET MAUI, then you can take a look on there. I'm sorry for that, but that will be 1 second at all. So yeah, there we go. So we have the actual implementation that is causing the leak. So I have the animatable there. Let's zoom it a little bit. And we have a wiki reference of the animatable. So far so good. We have reusing a wiki reference. So that should not be causing a memory leak. But then we have some overrides here on the equals and the get hash code. And on the get hash code, we have a strong reference to that object, that animatable object. because it is using to compute the hash code for this animatable key. And then we have the equals here that also is using the animatable here. And this actually was the causing of the leak. And why that? So let's jump into the animation extensions, and we have here a dictionary. And the dictionary is a hash map, basically. So it does the lookup using the hash, the get hash map method. And you may not know, but this collection will do a lookup on this collection a lot. Because every time that the animation ends and you say, okay, I need to restart this animation, so I need to find this animation inside the collection and create a animation action, let's say like that. And that animation, and that small animation will run the animation, actually. So this animation here is like the manager, and that will run the animation itself. So this happens a lot of times per second. And because of that, since this is a hash map collection, when I do a lookup on that collection, it will call this method a lot. And if you have a collision, we will also call the equals method. So during the GC collections, could happen that I am in the middle on the hash code mapping, or I'm in the middle on the lookup. And this here is a strong reference to this animatable object. And because of that, we will not be able to collect. So this will cause a memory leak. So just to a heads up there that you will not be able to, that just to use a weak reference sometimes is not the fix. So the fix here was something that I am working on. Then I will just grab the animatable hash here, and I will store it here to use on the get hash implementation. And on equals right now, I am just using the handle. And with that, the leak will not happen anymore. And if you take a look here to finish it on the fixed version, and if I search for animation, then you can see there is no more Microsoft maui.controls.animation. I will just have the static members living there and with one reference as it should be. And yeah, that's the two things that I have to show. So to conclude my presentation, that is on this QR code, the links to the references that I have, so my articles and also the videos that I mentioned there. Also, I am a consultant, so if you are struggling with the .NET MAUI, send me an email and let's talk and conversing about it. And I hope this presentation was really insightful for you and help you to debug your memory leaks. And yeah, that's it.